you guys could put your phones away, please. Put them under something, away somewhere. You're not going to be distracted. Unit 5, day 13. Okay. So today has the potential to be pretty short, and we might loop back a little bit and do that one question we didn't do yesterday. Maybe you remember from yesterday we did something called the fundamental theorem of calculus, and yesterday we did part 1. So naturally today we're going to do what's often referred to as part 2. There we go. And so kind of our setup for fundamental theorem of calculus part 2 is right here in this purplish bluish box. And I want to define a couple of things for you before I show you what this is, and then we'll kind of develop it and see how it works. And then I'm going to show you a trick. And listen, honestly, my full intent is that you would use the trick, because to be honest with you, that's going to be the only way to do these. Honestly, it's going to be the only way. So let's define a couple of things here. Some of it probably looks very familiar, maybe a few things not so much. U is going to stand for some function in terms of x. So some function in terms of x. So it might be as simple as just an x, or it could be like 5x to the negative third, whatever. It could be. It's just going to be some function in terms of x. T is what we call a dummy input variable. It doesn't really have to be a t. It usually is a t. And I call it a dummy input variable because aren't you thinking that the t should maybe be an x? Wouldn't that be standard? You with me? The only problem with that is if u is some function in terms of x, and then the x input for the f is also an x, well, those two x's would be the same x, and they shouldn't be the same x. So we just have to have some other variable besides an x. You kind of see how this pans out here in the end, but it's just a dummy input variable that has to be in there. We'll talk about how does this work here in a second. We don't often talk about this. The capital letter F, your book does this, and this is customary. Capital F stands for the antiderivative of lowercase f. So capital F very frequently is referred to as, or it notes the antiderivative of f. And there's one other piece of the puzzle up there that I did not say anything about, and that's the a. So I'll just put this up here. A is a constant, just some number, like negative 3 or 12. Yeah, so a is a constant, u is a function in terms of x, t is just a dummy input variable, capital F is the antiderivative of f. So I'm going to show you the trick here, and then I'm going to talk about how this works. You guys ready? Some of this is going to make sense, mostly maybe other parts won't. If I've got d dx, which means do the derivative with respect to x, so I've got the d dx of an antiderivative. That should catch your attention, right? These two things should be interacting in a certain way. So I've got an antiderivative there of f of t. This will end up equaling this. F of u times u prime. This will equal f of u times u prime. I'm going to show you how this works as well. Okay? So this really is just like I'm showing you the trick ahead of time, but I'd like to show you why the trick works. So here's what I'm going to do. I'm going to start off with d dx, the antiderivative from a to u of f of t dt, and I'm going to take this step by step. So let's see how much you guys remember from yesterday with FTC1, because we're going to use that here to help us. If I'm doing a definite integral, like you see in there, what's my very first step? Remember this from yesterday? Doing a definite integral, first step is always flip back if you need to. Say again? Find the antiderivative first. Doesn't the tall skinny s mean find the antiderivative? So step one is going to be to find the antiderivative. Here's what that could look like. It would be d dx, that has not gone anywhere, of capital F of t evaluated from the constant a to that function u. Obviously taking this in small chunks, right? So I just found the antiderivative, and that's it. Do you guys remember from yesterday, now once you found the antiderivative, what do you do with the u and the a? Plug them in and subtract. Okay? So this would be d dx, that still has not gone anywhere, of capital F of u minus capital F of a. Okay, so I've done everything inside that antiderivative. The definite integral is complete. Now I need to do the derivative. And let's remind ourselves, isn't capital F just the antiderivative of f? So what would you guys guess the d dx of capital F would be? Lowercase f. There you go. But let's remember that u is some function. So won't the chain rule matter? U is the input variable. Well, the chain rule is going to matter because it could be a complicated function. So let's go with what Cole said. This is going to be lowercase f of u. And according to the chain rule, it would be times u prime. Now let's remember, a is a constant, right? And I have no idea what this capital F function is. But if you have some function and you plug a constant in for the input, what always comes out?
Constant.
A constant. And what's the derivative of a constant? 0. So it'd be f of u times u prime plus 0, but obviously I'm not going to write the plus 0. And maybe you can see now how I came back around to this. So I'm showing you some really rigorous quality proof here. And now I'm about to say something that I hate, but I know works. I'm just gonna write this up here. And I want to focus on this trick, okay? So the trick is really, honestly, it's where it's at here. I want you to use the trick. So I'm drawing a box around this. I hate writing this because this is just like what I've written up there so far is really beautiful, good math. I'm about to write a little phrase that's just sort of like ugliness, but it works. If you recognize FTC2, here's what you do. Sorry, I need a little more space. Does that make any sense? I'll explain it if I need to. Here's what it means. If you recognize FTC2, check it out. You got to see the screen for this. Don't be looking at me. You need to drop. That's this. And derive. That's that. You get it? Please don't tell some math professor later on, oh, that's just when you drop and derive. No good. But does that help you remember it? Maybe? Okay. So you just drop the u in there. And of course, the d dx and the antiderivative, they cancel each other out. So you just drop that u in there, and then you multiply by the derivative. Drop and derive. Got it? So I'm going to say this again. This is going to be rare. Like most math teachers, I myself would hardly ever say this. I want you to use the trick. You have to use the trick. There are going to be some times where the only way to do this is simply to use this little FTC2. I call it a trick. I mean, I just kind of proved to you that it works. But that's going to be the only way. Okay? So let's take a look at, we have 3 examples, and that's it. These are going to be pretty quick. Why don't we kind of do the first one together, see how you're doing with this, and then we'll see how you do with the rest of them. So I wrote there, because the antiderivative of f will often be inaccessible / impossible, perhaps for everyone, math PhDs included, it's best to just remember to use this FTC2 trick when you recognize that it's FTC2. And by the way, how on earth are you supposed to recognize FTC2? What are some symbols that tell you that it's that? Cole, what do you see? Yeah, I mean, that's in a nutshell, that's it, right? It has to have a ddx, it has to have an antiderivative, and it's got to have one of those limits has to be some function that we called u before. So check it out. Number 1, Do you recognize all those things that Cole just mentioned? You've got a ddx. You got an antiderivative, and one of your limits is constant, and the other one is some function in terms of x. So, have you looked at the integrand yet? It looks sort of innocent, but it is a horrific mess. Like, if you feel like wasting your time, try it. It's not going to go well. This doesn't. It's. I said inaccessible, right? This is one of those inaccessible antiderivatives. So here's my thought. You would look at this just like Cole did. He mentioned, hey, there's a ddx, there's an antiderivative. Oh, look, it's a constant and a variable for the limits of integration. I'm thinking maybe in your mind what you would do is you would say, let's drop and derive. Here's what that would look like here. Drop. There's my drop. See how I just like dx replaced the t? I drop. There's my derive. So the
3x squared?
What's that?
Would it not be 3x squared?
No, you multiply by the derivative of what you dropped in. Multiply by the derivative of what you dropped in. Can we explain why I wouldn't have to put a plus c on the end of this? It's a definite integral, and I just took the derivative. So there's like a double reason why there shouldn't be a plus c here. Subtracted it out with the definite integral. We're going to do the derivative anyways. Okay, so you guys ready to practice the next two? There is no other shoe that's about to drop. I'm not about to say, oh, and these get way tougher. Like, this is it. So see if you can do numbers 2 and 3. Here they are on screen. Check them out. I hope you recognize all those characteristics that Cole was talking about that are all there still. I'm going to give you a couple more minutes here to finish out number 2. We'll check an answer for 2, and then if you need a few more minutes to work on 3, you can have that as well. Remember, just drop it in, multiply by the derivative. Drop and derive. You guys ready?
Yeah. Okay.
Are they good?
They're all right.
Another good volleyball. Oh, they did? Graduated? 70, man, yeah, that's automatically hard to guard and hard to deal with rebounding. Is there any rule that says like you could like sit on Colbox's shoulders to rebound? Not that that would work very well, but you know. At least you get out rebound. Yeah, he'd not be very fast. Their height doesn't matter as much. But if they're good, at times you got it blocked out perfectly and he just like reaches out. What are you going to do? Oh, really? Oh, yeah, like Big Castle Rock. All right, so number 2. Hey, listen, this is one of those things that's like easy enough. We really need to talk about like what's going on in your brain, what you're thinking about. So again, I want to remind you that you want to notice all these characteristic symbols, right? You're doing ddx of an antiderivative, and one of the 2 limits is, in fact, specifically the top limit is a function. So when you have these characteristics going on, this is FTC2. You're going to use this FTC2 trick, aka drop and derive, right? Drop it in and derive. So here's what this would look like. This would be e to the x squared to the fourth. Does that make sense? You just drop that x squared in wherever the t is. So it's e to the x squared to the fourth times the derivative of what you dropped in. So in this case, that would be 2x. And of course, this is a fine form right here, and you could leave it like this. But let's just be honest. If you didn't simplify it because you don't know how to simplify it, that's a big problem. So let's simplify it to make sure you see it one more time. If you have a base to a power to another power, what do you do with those exponents? You multiply. So this would be e to the x to the eighth, and then still times 2x. How's FTC2 going? Again, I promise you I'm not about to say, this gets way tougher. This is it. Just be good at it. Okay. All right, so again, as promised, maybe take another minute or two to work on number 3. I'm looking around. Yeah, a couple people are writing. I'll give you time to finish up number 3, and then we'll actually go back in time and we'll catch that one that we didn't do yesterday. We kind of didn't do one and a half yesterday. Cole, what's the U.S. jacket all about? So this is you're basically national team for what? All right. Hunter, let's rejoin us in the real world. Number 3, as I pick up an iPad. All right, number 3. Again, I'm hoping that you notice the ddx of an antiderivative and that your upper limit is a function in terms of x. And hopefully when you recognize those things, your mind says, hey, that's that FTC2 thing that we talked about. And the dumb little trick is drop and derive. So we're just going to drop this 4x in wherever you see a t. So this would be sine of 4x quantity squared. And then we would multiply by the derivative of what you dropped in. So it would be times 4. You could leave it just like that if you wanted to, or you could make it sine of 16x squared times 4. Something like that would be fine. Okay. Just like trying to read the room here. I feel like you're thinking this was pretty good. Not too bad. Okay. Good deal. So let's flip back a little bit. Let's see if we can tie yesterday into today a little bit. This is it for FTC2. So we'll practice a little bit more in the coming days. But for now, I'd like to go back and I would like to hit number 4. Number 4 is one that I didn't touch on at all yesterday. This might be a good opportunity to kind of review that FTC1, which we sort of used that today in the little derivation. But see if you can do number 4. Let's see how the rest of this goes. Please do compare your answers as you start towards the end. I agree. And the reason why is I don't really think we should here. So I always go straight. Basically like those orders. So I can tell that some of you guys have reached an endpoint here, so I'll just flash the answer up on screen. If you don't want to see it, don't look up. If you want to see it, check it out. Just ran over the arithmetic again in my head, and I think it was pretty good. So I know we didn't totally finish number 5. I know we kind of started that yesterday. I'd encourage you, if you're done with 4, we still have about 5 minutes to see how far you can take 5. And I'll just flash answers up there. I know we got to like maybe the 3rd step or something on number 5 yesterday. Be worthwhile to see if you can wrap that one up as well. For those that are curious, if I remember correctly, I was looking at the calendar today. I think that our test over Unit 5, let's see, today's Thursday. I want to say it's like 2 weeks from yesterday, or it might even be 3 weeks from yesterday. Think about that. I think it's 3 weeks from yesterday. So you got some time to do retries. We still have one more quiz to handle out of this. So it's got to be 3 weeks from yesterday. That's got to be what it is. So be on those retries. Got a good healthy dose of retries today. And oh gosh, I can't say this for certain, but I believe everyone improved their score. I believe.
When's the next quiz?
Let's see here. So we have 2 more days with FTC. So I'm going to guess. For sure. So like next Tuesday and Wednesday will be FTC. So I'm guessing probably Friday. I think it's probably the Monday after or something like that. Yeah, we got two more pretty good things to cover with this final term. Any questions on 4? I think the steps are fairly well written, but maybe if something's not clear, I'm not going to be insulted or sad. You have to explain. Hunter, you done with 5? Mm-hmm. I'll get that answer up there. Just, I don't know. Is everybody good with 4? I'm just trying to read. No, even like a little minor question. Big question, I don't care. Joe, I think you're thinking about something, but I don't know what you're thinking.
I'm just trying to think if there's anything I don't understand.
Okay, fair enough. Cole, what's up?
This is a composite, right? Like there's 2 separate ones?
Number 4?
Yeah.
So I would say number 4 is not a composite because I don't see any function as the input for some other function. We do need to flip up, right? I mean, that 1 over x squared, 1 over x cubed, we want those flipped up like I did in my first step there. But from there, I don't think there's any need for like a substitution, just because I don't see a composite. Yeah. Okay. Well, I'll show you number 5. Probably some of it looks familiar because of what we did yesterday. If you want to check your answer, that's what I got. Pretty sure it's right. One of those examples where the calculator might be active, and if it was, we would do something else entirely. The calculator's not active, I think you kind of have to end up at that answer, unless you decided to get a comment on your NAD or something like that, but I don't know how you feel about that. Some people look at that answer and they're like, oh, it's such an unsatisfying answer, because it's just like, you know, it's not like a decimal. I think that's a very satisfying answer, because it's exact, there's no rounding or ugly decimals to write out, it's just, it is what it is. So, beautiful number. Slightly less than 2, I guess. Yeah, just a little bit less than 2. All right, I don't know if this feels weird, but we didn't redline it until the end. Shocker. Have a great day, you guys.